Alright, so let's look at some of the features of ANOVA. We've looked already at what the purpose is, to compare the means of several groups. What about statistics? Okay, the ANOVA requires means, sizes, sample sizes I mean, and standard deviations. So just like the t-test. But notice that in the t-test we only used two groups, so that it was only at most two means, two sample size, and two standard deviations. Here we may have more than that, so it requires more statistics. It also produced some statistics that have some special technical names. One of them is called the sums of squared errors, which is related to the variance, and another one is called the F statistics. F as after Sir Ronald Fisher that we saw earlier with this Fisher's exact test. So these statistics are often presented when the authors are using the ANOVA, okay? But remember, these are reported but seldom informative, just like the chi-square statistic and the t-statistic. So if you find them, just say, oh yeah, that must be because they were using ANOVA, but don't worry too much about their values. What are the requirements of ANOVA? Well, as I've introduced the whole test to you, you may have noticed that there are several requirements. So let's go through them and make sure that we understand what they are, because again, ANOVA is quite finicky and it does require these requirements. Okay, so what are they? So first of all, probability sample of independent observations. This is fairly standard, so we're assuming that we're doing a probability sample, and we're assuming that the observations are going to be independent of each other. So this is basic and fairly routine requirement. Now the next one is ANOVA really requires equal sample sizes in all groups. We can move a little bit from this one, but really theoretically we should have equal sample sizes in all groups. Now here is the first big one. Just like the t-test, for ANOVA the variable should have a Bell distribution, but it should have it in each group. Okay? And of course, because ANOVA is comparing more than two groups, that means that now the requirement is easier to have failed, because if one of those groups does not have a Bell distribution, then we may be in trouble. So theoretically we should check each of those groups. The other one is the one that we're just talking about recently. The variability should be the same in all groups. Okay? So if we're trying to compare groups, one of which has a variability substantially different from the other ones, then ANOVA may be influenced by that and give us the wrong conclusion. Okay? So again, think of the basic idea on how it works, and you realize that this requirement is very, very important. Finally, because of the fact that all these requirements are seldom exactly true, then we should always think that ANOVA's p-value is approximate. Again, this is nothing new. We have seen it in other tests as well, but the more finicky the test is, the more this is important to keep in mind. So because ANOVA can be quite finicky and has lots of requirements, how about its robustness? Well, you're not going to be surprised, I hope, to know that it's not very robust. Okay? Now, if we have differences in the variability of the groups or in the sample sizes, well, that's not a big problem. Okay? But if we have larger differences, or if we have some of the groups that are really not bell-shaped or are substantially different from bell-shaped, then this can lead to wrong results. And remember, as long as one of them is not bell-shaped, that can affect the results of the whole test. Now, so what should the authors present in order to check that these requirements are satisfied? Well, my suggestion is to do what I've just done, namely present box plots or at least histograms. And you're going to find that ANOVA is even worse than the t-test in the sense that these box plots or histograms are seldom, if ever, presented. And this is a major problem that you're going to have to deal with. What if the requirements are not satisfied? Well, just like for the t-test, there are other tests, okay, which are less demanding, so whose requirements are not as strong and therefore can be used. And as we noticed for the t-test, the flip side of that is those other tests will be less powerful. So ANOVA, when it comes to doing its job, when the requirements are satisfied, it does it very well with good power and gives us really reliable conclusions in terms of p-value. However, remember, if the requirements are not satisfied, that p-value could be totally wrong, and so it doesn't matter what power it has. If it's wrong, it's wrong.